Good morning, students. So this is our second class and this is chapter 2, motion in one dimension. Okay, so first of all we need to know what is the meaning of this one dimension. Okay, I think you know better than me. Okay, then also I am telling you. So let's say I am taking some coordinate axis. Let's say this is x-axis and this is y-axis, and I'm drawing a line here. And when I'm drawing a line in this coordinate system, then of course this is not one dimensional, rather this is a two dimensional line. Why this is two dimension? Because if you just look at the line, some of its parts is extended along x and after that along y. Okay, so this line is basically spread on xy plane, that is why this is a two dimensional line. Then what is one dimensional? Yes, it is either should be x or y. Okay, then this line, this is a one dimensional line, this is a one dimensional line, and this line, this is also a one dimensional line. Okay, so let's say a car is here which is traveling along this line, so its motion must be one dimensional. Is it clear? So this is one dimensional, means you are traveling in a straight line, so this is so far one dimensional, but when you are turning, this is not one dimensional, this will become a two dimensional line. Okay, and what about three dimensional? You are turning, after that you are coming up. Okay, this is three dimensional. Okay, so this is one dimensional. Okay, now according to your book, the first topic, that is scalar and vector, that is physical quantity, scalar and vector, scalar and vector. Now what is a scalar quantity? Scalar and vectors are physical quantity, we know. What is a scalar quantity? It should have only magnitude. It should have only magnitude or value. Okay, actually magnitude means value. Okay, I am giving example, just give me a few minutes. And if we talk about vector, it should have a magnitude as well as a direction, Okay, if I ask you what is your age, you will tell me I am 14. Okay, so your age, that is a scalar quantity. Okay, if I ask you, suppose you are riding some car, what is your velocity? Then the velocity will be a vector quantity. Suppose you are telling my velocity is 40 km per hour, that is not enough, that is the magnitude 40 km per hour, but you have to tell me the direction, that is from your school to Bonga or from your school to Chatpara, like this. Okay, so when you are asking about scalar quantity, only magnitude will be enough, but in case of vector quantity, magnitude plus direction you have to mention. Okay, so what are the example of scalar quantity? We know that is some volume is a scalar quantity. Okay, density is a scalar quantity. Okay, and in case of vector quantity, displacement is the vector quantity. Velocity is the vector quantity. Okay, here speed is the scalar quantity, distance is the scalar quantity. Okay, here acceleration is the vector quantity. Okay, so this is a brief idea about scalar and vector. You will get more scope to read about scalar and vector in class 11. Okay, and there you will find a chapter only upon this vector, whatever. So next topic is distance and displacement, that is we are going to explain some physical quantity which are related to motion in one dimension. I think it is clear now what is motion in one dimension, what is scalar, what is vector. Oh, before that another topic is here, that is rest and motion. Suppose an object is here which is not changing its position with time, then this is at rest. Okay, and another object is here which is changing its position or what's the orientation with time, then this is in motion. Okay, you know this because you are reading this from class 6. Okay, now the first topic is here, distance. distance. So what is distance? Suppose this is a point A and this is point B. This is point B. So suppose you are traveling from A to B via a path, this path. Okay, this is the path and you are traveling by this path. So the total distance, that will be the total length of this path. So this is distance. So distance means nothing but length. Okay, so unit of distance is the unit of length, that is either meter or centimeter, not meter per centimeter, either meter or centimeter. Okay, so dimension of length, that is not given to you, but this is the SI unit and this is the CGS unit. Moreover, this is a scalar quantity. This is a scalar quantity. No need to specify the direction here. Okay, after that, the next topic is the displacement. Displacement. First, let me tell you, displacement is a vector quantity. Displacement is a vector quantity. So here, let's consider this case. From point A, you want to go to point B. Okay, the shortest distance, that will be called the displacement. What I am telling, the shortest distance, that will be called the displacement. So here the displacement is AB, and just look at this AB, that is also a length. So the unit of displacement, that is also meter and centimeter. Meter is the SI unit, CGS is the centimeter is the CGS unit. Okay, but this case is special because this is vector, so you must have to mention its direction. What is its direction? From A to B. From A to B, this is its direction. Is it okay? So this is displacement. So distance is a scalar quantity, displacement is a vector quantity, and vector is the and displacement is the smallest distance between two point, not distance. Is it okay? Okay, after that we shall talk about speed. Okay, after that we shall talk about speed. Okay, before that, let me give an example. Let's say at first you are point A, then you are going to point B, after that you are going to point C. At first you are here, then point here. So what is the displacement here? The distance between the initial and final position is the displacement. So your displacement is AC, from A to C. Okay, next, the next topic is speed. The difference between distance and displacement, that will be important. Okay, so speed, what is speed? The rate of change of displacement or distance, the rate of change of distance. Okay, that is speed. Distance or displacement, we shall denote it by x. Okay, so the rate of change of distance, that is known as speed. Let's say this is a point and this is another point, and someone is going from point A to point B at time t. Total distance covered, that is x. Then speed, it is denoted by v. Speed, it is denoted by v, equal to x by t. X by t. Let me tell you another thing. The vector quantity is denoted by this type of symbol. A symbol, let's say A, with a arrow on its head. Arrow on its head. This is very much important. So displacement x, but it must have a arrow on its head. Okay, but speed, that is a scalar quantity. Speed is a scalar quantity, so no need to give an arrow. Okay, so speed, that is equal to distance by time. Is it clear? Distance by time means if you want to write the unit, if you want to write its unit, so the unit of v, I told you last class, is third bracket, means the unit, that is unit of distance by unit of time. So unit of distance, meter or centimeter, and time is second. So meter per second is the SI unit, meter per second. And if we talk about CGS unit, then this is centimeter per second. Centimeter per second, this is the CGS unit. And as this is a scalar quantity, so no need to mention the direction. Actually there is no direction, as this is scalar quantity. Okay, so how to calculate this? Just look at this. v equal to x by t or x equal to vt. So the total distance covered, that is equal to speed into time. This is the formula you need. This is the formula you need. Okay. Okay. Next, that is instantaneous speed. Instantaneous speed means, suppose you are traveling from your school to your home. Okay, I am asking you, what will be or what was your velocity when you just crossed a lamppost? Specific lamppost is there. When you just cross that lamppost, that means at that moment what is your speed? That is known as the instantaneous speed. And what is that instantaneous speed? Instantaneous speed means distance traveled in that short instantaneous time divided by that time. That is instantaneous speed. It's very much easy. Basically, when the total distance before covering the pole and the distance after covering the pole. So x2 minus x1 is the delta x. And this is the instantaneous time. That's mean the time taken by you to cross the lamppost. Okay, so this is instantaneous time or instantaneous interval. Okay, so instantaneous speed, just to take a look from the book. Okay, after that, average speed. What is average speed? Suppose you are traveling a distance x1 in time t1, after that x2 in time t2, and then x3 in time t3. Time t2 in time t3. Then what is your average speed? Your average speed v will be total distance covered, that is x1 plus x2 plus x3, by total time, that is t1 plus t2 plus t3. T1 plus t2 plus t3. Is it clear? This is the average speed. This is very much important. Okay, after that, velocity. Just take a pause or rewind the video and revise the speed. Okay, is it done? Now new topic is velocity. Let me tell you, velocity is a vector quantity. That means it must have a direction. Okay, so velocity, I have told you speed was the rate of change of distance. Now velocity is the rate of change of displacement. So velocity it is a vector quantity, so we have to give an vector sign or a arrow sign, that is equal to distance by time. Distance by time. Okay, it must have the same unit, meter per second, centimeter per second. Okay, this is the SI unit, this is the CGS unit. Okay, so here one thing is here, that is uniform speed or uniform velocity. I have missed here uniform speed. So uniform speed or uniform velocity, both are the same actually, but this is vector and that is scalar. It is when you are traveling same interval in same time, then the velocity will be called uniform velocity or the speed will be called uniform speed. This is from class 8. Okay, and when you are traveling different speed in same time, different distance in same time, that will be called the uniform speed. Okay, a non-uniform speed, and in case of velocity, a non-uniform velocity. Okay, and instantaneous velocity is again here, that is like this, the short displacement, the display or by the time interval. Okay, and the average velocity is also like this, the average velocity, the total displacement covered by total time, that is average velocity. And velocity is a scalar quantity. Okay, let me give an example. Suppose an object is moving in a circular path. An object is moving in a circular path. Okay, so let's say the speed is same, but the velocity every moment is different. Why the velocity is different? Because it is changing its direction every time, because it is changing its direction every moment. So that's why its velocity is different, because velocity is a vector quantity, and when it changes direction, then also it is changing the velocity, because velocity depends upon direction plus the value. So maybe its values are same, but the direction are different, so that's why the velocity will be different. Is it clear? So it is very important that what is the difference between speed and velocity. Okay, what is the difference between speed and velocity? That is an important topic. Okay, let's go to the next topic. Next topic is acceleration. Acceleration. So acceleration means when you are changing the velocity with respect to time. When you are changing the velocity with respect to time, let's say for few interval you are at a speed 10 meter per second, after that 15 meter per second, after that 20 meter per second, like that you are changing your velocity. So the rate of change of velocity with respect to time, that is known as the acceleration. And acceleration is also a scalar quantity. Acceleration is a scalar quantity. Acceleration. So acceleration will be denoted by a with vector sign. So this means change in velocity, change in velocity by time interval, by time interval. So what will be the unit of acceleration? That is the unit of velocity, because the unit of change in velocity and unit of velocity are same, divided by time. So velocity, the unit of velocity, that was meter second inverse, and now another second inverse. So meter second to the power minus 2, that is the SI unit. And if we talk about CGS unit, then centimeter second to the power minus 2, this is the CGS unit. So alternatively you can write meter per second square or centimeter per second square. This is the unit of the acceleration. This is very much important, you have to remember. Okay, now so change in velocity, let's say I'm talking about a particle initially which is moving with velocity u, and after some time t, let's say its speed become v, where v is greater than u. That's mean, what is the change in velocity? So the change in velocity is v minus u. And what is the time? Time is t. Now this is equal to a, so a equal to v minus u by t. Okay, here v and u both are the scalar vector quantity. As all of them are vector quantity, now I am just ignoring this arrow sign. Okay, so from here we can write at equal to v minus u, or here from here we can write v equal to u plus at. So this is a formula you need to remember, and this one also, this is very important formula. Okay, and examples are there in the book. Okay, on page number 31, just have a look. Is it okay? Okay, so acceleration is a vector quantity, you already know. Okay, so variable acceleration, that is not a topic of our interest. Okay, but what is retardation? Acceleration is a scalar, sorry, is a vector quantity, sorry. Okay, so what is retardation? Basically, in case of acceleration the speed is increasing, and in case of retardation the speed will decrease. Okay, then the equation will be u minus v by t. Okay, then a equal to u minus v by t. So this equation will become v equal to u minus at, like this. Basically, if a denotes the acceleration, then minus a denotes the retardation, nothing else. And you must have to mention the direction, as it is a vector quantity. Okay, so this is the end of unit 1. Okay, practice the numericals. See you in next video.